I know how much you guys love systems, so guess what? We're going to put two of your favorite things together, systems of equations and word problems. What a fun time that's going to be today. So, honestly, the systems can be used to solve some real life problems from time to time. So that's what we're going to look at. Here are your steps. Highlight the important information in the problem that will help you write two equations. Okay, so if we look at our first problem here, example 1, it says last year a baseball team paid $20 per bat and $12 per glove, spending a total of $1,400. This year, the price went up $25 per bat, went up to $25 per bat and $16 per glove. The team spent $1,350 to purchase the same amount of equipment as last year. How many bats and gloves did the teams purchase each year? So we want to underline or highlight important things. So we can say last year was $15 per bat, $12 per glove, with a total of $1,040. This year, prices are now $25 per bat, $16 per glove, and they spent $1,350. And we want to know how many bats and gloves did they purchase. All right, after that, you always need to define your variables. Define your variables. So the variables are what we don't know. And in this case, we want to know how many bats, we don't know that, and how many gloves they purchased. We don't know that either. So therefore, our variables are going to be x is equal to number of bats, and y is going to be number of gloves. Be very specific and write number of, because it's not the cost, it's the number of. All right, we go to step number 3. Since we have two variables, we need to write two equations to solve. So that's step 3, write two equations. All right, so these equations are going to be in standard form because we have a total. Remember, whenever there's a total, that is always going to be our standard form, ax plus by equals c. So therefore, we spent $1,040, so that's our total on our right. And how did we get the $1,040? Well, it was $20 times the number of bats. So I'm taking 20x, because 20 times x means 20 times the number of bats. I added to that $12 times the number of gloves, which would be 12y. And so this is saying, translation, $20 times the number of bats plus 12 times the number of gloves equals $1,040. Now, we also have to write an equation for the second year, or this year. And so now it's $25 per bat, 25x, plus $16 per glove, 16y, equals 1,350. We are then going to use one of the methods for solving the system, whether that's substitution or elimination or graphing, depending on what the directions say. After that, make sure to check your answers to make sense in the context of the problem. So we'll go ahead and solve this and then make sure our answer makes sense. So our answers here, since I don't have a graph, I would say substitution or elimination, and I would personally pick elimination because everything's lined up. And what I see here is I see a 20 and a 25, and I know 100 is a multiple of 20 and 25, meaning I can take 20 times some whole number and get 100, and 25 times some whole number to get 100 as well. So I'm going to multiply my top equation by 5. So I'm putting the whole thing in parentheses, multiplying the whole top equation by 5. 5 times 20 is 100x. 5 times 12 is 60y. And 5 times 1,040 is 5,200. Now, since I made this 100x, that means in my next step I need to have negative 100x. And the way I can make that negative 100x is by multiplying by negative 4. All right, so I'd have negative 4 times 25 is negative 100x. Negative 4 times 16 is going to be negative 64y. And then 1,350 times negative 4 is negative 5,400. I can now eliminate 100x minus 100x. Get your laser beams out. Boom! 60y minus 64y is negative 4y. And then 5,200 minus 5,400 is negative 200. Which I can then divide by negative 4. And I end up with y equals 50. Now, we had to make sure that this answer makes sense in the context. 50. Well, 50 gloves. Yeah, that seems like a reasonable answer. It would not be reasonable if I got a decimal here, because I can't have part of a glove or buy part of a glove. What also wouldn't make sense is if I got a negative 50, because you can't have negative gloves. So in this case, we were really looking for a positive whole number. And in this case, we got 50 gloves. We still need to know the number of bats, though. So once we know that, I can plug the 50 in for y in either equation. I'll plug it in the top equation, 20x plus 12 times 50 equals 1,040. I'm going to multiply the 12 times 50 and get 600. And then I'm going to subtract 600. 20x equals 440. And 440 divided by 20 is 22. So the last thing that we need to say is write our answer in terms of the real world context or problems. So we are going to say they bought 22 bats and 50 gloves. And that's your final answer. All right, try doing example 2, writing the equations first. We will define our variables together. So it says, while she was on vacation, Tara sent 14 letters, 14 friends, either a letter or a postcard. So 14 friends, I'm underlining. She spent $3.92 on postage. If it cost 23 cents to mail a postcard and 37 cents to mail a letter, how many letters and postcards did Tara send? And we are going to write a system to represent the situation and then solve for the numbers of letters and postcards. So define your variables first. All right, I'm going to say x equals number of postcards. I'm going to say y equals number of letters. Now that we know that, the first equation is going to be talking about the total of everything. So she has 14 friends. That's the total. And what did she do to 14 friends? She sent letters or postcards. So the total number of postcards, which is x, plus the total number of letters, which is y, has to equal 14. We are then going to have what I call a money equation, because this equation is going to deal with the money. So she spent a total of $3.92. So again, anytime it's a total, you write that you write it equal to 392. And what equaled 392? It was when she took the postcards, which were 23 cents each, multiplied it by our number of postcards, so 0.23 times x, and added to that the number of letters sent, which is y, and the cost to send each letter, which is 37 cents. So my second equation would be 0.23x plus 0.37y equals $3.92. From there, we can choose whether we're going to use substitution or elimination. In this case, since I have a 1 in front of these variables, I would actually probably use substitution. And I'm going to try and get the y by itself. So to get the y by itself, I'm going to subtract x. So my equation would be y equals negative x plus 14. And I'm going to take that and put it in for y in my other equation. So that would give me 0.23x plus 0.37 times y, but y is equal to negative x plus 14. That's equal to $3.92. I'm then going to distribute my 0.37. So I have 0.23x plus 0.37 minus 0.37x. And I'm doing 0.37 times 14, which is 518, plus 518 equals 3.92. I add my like terms, so that would be minus 0.14x plus 5.18 equals 3.92. I'm going to subtract 5.18, and I get negative 0.14x equals, and 392 minus 518 equals negative $1.96, which I can then divide by negative 0.14. And I get x equals 9. So what that tells me is I know that she sent 9 postcards. For me to find out the number of letters, I then go and plug my 9 in for x here and get 9 plus y equals 14. Subtract 9, and I know she sent 5 letters then. Do those answers make sense in terms of the context? Absolutely. You cannot send negative letters. You cannot send negative decimals. So if I end up getting a decimal or negative here, I know I made a mistake. I did not, so these answers make sense. And just last thing is write a short statement. She sent 9 postcards and 5 letters. All right, there you have it.